Hey, Dr. B here, and let's give you some assistance with the third lab in module number 5. This is the Blackboard home page. Here is module number 5. Let's go forward to lab number 3. There's lab number 1, 2, and 3 begins here. Now I've started to create this assistance video, so you'll see it says assistance here. I'll provide a link on here that says here's some assistance with this video. And let's just do what it says. So it says go to this particular lab, so I'm going to go ahead and go to where it says to go. And there it is. Fine. Beautiful. And there's the Cobalt lab. If you click here, you'll get the instructions, right? Add 25 mils of Cobalt H2O6 plus 2. They're being kind of cute there. That's what you get when you simply take cobalt chloride and dissolve it in water. It'll form cobalt ions and it'll form chloride ions. When it dissolves, that's what salts do. The ions separate. Cobalt happens to form a hexahydrocomplex. It means 6 water molecules will complex them around fine. So what they're really saying is just grab some of that cobalt chloride and add 12 molar HCl in 1 ml increments until the color changes. Let's go ahead and do that. So let's put the cobalt chloride solution out there. Oh, I noticed the we also have the 12 molar. I'll need some of that. And let's grab an Erlenmeyer flask as well. Fine. And first, let's pour 25 mils of this into there. Done. And let's pour this in 1 ml increments until it changes color. Now, I already did this, and it changes color slowly. There's going to be a lot of different answers here, because watch what happens. That's 1 ml. See how it went up to 26, 27, 28, 29, 30. Now, I'm already seeing it changing color. But it hasn't really turned a real color, so why don't I wait until it turns maybe bluish? Oh, that's fine. Now, can you see how everybody's going to get different answers? It's definitely a different color, but it started really a few mils in. So I'm going to say that I added from, wow, was it at 25? I'm now at 47. So I will enter that I added 22 mils of this stuff. What was the minimum mils for the color change? You know, I'm going to type in 22 ml. I'm going to make that red so it's easy for my professor to see it. I'm going to make it bigger for him. I'm even going to center it because I'm like that. And that's a beautiful thing. Include a screenshot after the color changes in this box. So I would then go back to it and I would go ahead and take a screenshot showing that it changed color. And even showing that it's now at 47 mils. Okay, so I would have that. And I've taken the liberty of pasting my screenshot right where they asked us to do that. We're now up to here, and I think these numbers really are wrong. I am going to change that to 2 and that to 3. That seems a little better because it says here it's like predict the effect of removing chloride ions, la la la. Now here it says, now remove some of the free chloride ions by adding silver nitrate. So we have to do something to make it happen. If you think about it, cobalt chloride plus HCl, well, it's got a chloride in both sides, so there's no reaction that will occur. You simply will have a greater concentration of the chloride ions when you add HCl. Now we want to get rid of some of those by adding silver nitrate. So the reaction must be that those chloride ions react with silver cation to make silver chloride precipitate. That does get rid of them from the solution. So it says add 1 millimount of the silver nitrate successfully until the equilibrium has been shifted instead of adding a whole bunch once. So 1 millimount each. So let's go here. Let's grab I'll bet they have some silver nitrate solutions, don't they? There it is. And let's add it in 1 mils at a time. So 1 mil. pour. So it went up from 47 to 48. That's 1 mil, 2 mils, 3 mils, 4 mils. Keep going. We should get a change in color sooner or later. Is it changing? Yeah, I think it is changing. Look, it's back to the red. Ha ha. So I went from 47 to 96. Why don't I give it 1 more mil to make that 50 mLs that I added? And take a screenshot after the equilibrium has been reached, so it got colorless again. So I'm going to do that and show you that after I added 50 mils, it in fact did turn that color. And I went ahead and put the screenshot right there. And now it asks a couple of predictive questions. What do you predict the effect of removing chloride ions will be? It also asks you, what do you predict the effect of adding HCl, which contains chloride here? I think these two answers should be the opposite of each other, and you can think about Le Chatelier's principle, which states that adding a reactant will generally shift the reaction to the right. Removing a reactant will shift it to the left. Adding a product would shift the reaction to the left. Adding a reactant would shift it to the right. So use those sort of concepts in order to answer that question. Now it asks us to add some chloride in the form of hydrogen chloride in small increments. As you've learned, that means 1 mil at a time, and see if it shifts. So I'll go ahead and grab the HCl, and I'll make it 1 mil increments, and let's see what color it turns. Now we are at 98, so close to 100. Just remember, I think we're at 97. So let's go forward until it changes color. Ooh, it is. It's a beautiful thing. I think I'll wait until it turns bluish. Close enough for me. I went all the way from 98 to 160, so I'm just going to record that it was 62 mils. And it says insert your screenshot, so I will. And I don't really need too much, do I? I just need to show that it's now that color and that volume. And then it asks to paste it in, so I will. And make it nice and small. Get it in there. And we've accomplished that part. Okay, it says now let's see how this reaction equilibrium is shifted by a change in temperature. Click on the right and choose thermal properties. You can now change the temperature between 0 and 99. Heat or cool the system until you've perturbed the equilibrium. So I've gone ahead and grabbed a Bunsen burner from the stockroom. Just so you know, I got it from the tools. There it is right there. So I think all you need to do is, at least this is all I did, was just put it underneath. See how we're at 25.9? Ha ha. All right, look at that change temperature. I'll pull it away when it gets up to, I don't know, and if it changes color. Is it changing? We are at 40. We're at 50. You know, I don't see much change going on, right? It's staying bluish. It's not turning to this color. But maybe when it gets up to 90, we'll go all the way to 90 just to see if it changes color. And I went all the way up to 90 something. I didn't want it to boil. See how it's going back down? Fortunately, nice and fast here. I did not see a color change by heating it. But it did say that I could make it cooler by right-clicking, pressing thermal properties, and just picking a number. Now, I don't want to freeze it, so I think I'll just pick 2 degrees Celsius and see what happens. Okay. Aha! I'm guessing we'll need a screenshot of that. And I better hurry because, look, it's already going up. So let me actually get it back to that temperature. So thermal properties, 2. Okay, good. I got that color, and I better get my screenshot in. And that's all we really need, I think. And I got it. Copied it. And now I want to paste it into my document. I have a feeling, right? There it is. And that works for me. And at this point, you can try to explain these results. You may recall that an endothermic reaction needs heat, and if you apply that heat, it will shift to the reaction to the right. An exothermic needs heat removed from it. So if you remove heat from that system, it will cause a shift to the right by removing heat. So use that logic to help answer that question. Okay, now it says finally, let's calculate the value of the equilibrium constant at two different temperatures. This should show if it's endothermic or exothermic. Allow the system to equilibrate. I think it has by now. Use the concentration values to determine K. Concentration values, oh, they're right here. So I think I will make a copy of those. There. And there it is. And I think I will put those in here just so I know. There's my volume. There's my volume, 0.16042 liters. Here's the concentration of everything. Sadly, I'm not going to answer this for you. You'll have to figure out how to do that yourself. And then it says, now get a different temperature and use the thermally isolated system. I think that's just so it won't go up so fast as soon as you get there. Remember how I had trouble taking the screenshot? And get the K at the new temperature. So let's go ahead and right-click on this thing, which I already did here. So let's X that out. Right-click on it. Thermal properties, insulate it from the surroundings. Let's again go to 2 degrees, and I'll bet it'll change color. And it does, and it holds that temperature. Well, thank you. And here's my new data at 2 degrees Celsius. So maybe I'll take a picture of that, which is, I think, just, I'll include the Erlenmeyer flask. Here we go. There. And copy that, paste that in, and there it is. Make it small. And that would be the information that I'd be using over on this side. So I'll just put it like that. So that's enough data for you to get your K value on this side. That's enough data to get your new K value on this side, because look, you have a new temperature, and then I'll let you answer those 3 questions on their own. Hint, you really learned what happened in the previous slide when you learned that by cooling it, you got the change in color. That should indicate whether it's endothermic or exothermic and how K would change with those 2 temperatures. So that should help a little bit. And at that point, you only have to answer these 3 questions based on the colors of the reactants and products. Which do you think is in higher concentration? In the flask of 0.1 molar cobalt chloride when you started? What happens when you added HCl? How would that shift the equilibrium? Did you add a product or a reactant in order to shift it? Describe what happens when you added silver nitrate. What does the adding of the silver nitrate do to the reaction? Answer those 3 questions based on what you saw. And that ends the lab. I hope this was helpful to you guys, and as always, email me if you have any questions.